So how can we get then from the idea of a continuously varying vocal tract that could make any sounds to some sort of categories of sounds that one particular language might use? So for that, we need to have another view of things. And we need to think about how to put names on things that have got continuous values. And this is not a complete course in acoustic phonetics and certainly not a course in phonology. So I'm not going to get into the theory of exactly where these boundaries are formed. But intuitively, it seems quite reasonable that of this infinitely variable space of sounds that we can make with any value for either of the two formants, we might want to pick certain points in that are very acoustically different from each other. That's going to be easier to produce them because you won't need to be very precise about how you produce them. And it's going to be easier to perceive them because they'll be so different from each other that listeners will find it easy to tell which one it is that you're saying. So we think about how we would definitely not do things in language. So we've got this chart here, which is this sort of things in formant space. Don't worry about the axes being inverted. It's just so that it looks the same as the traditional way of drawing the IPA chart. What we wouldn't do in a language is pick a set of vowels that are all close together. So we wouldn't pick vowels like this in the corner of the space. Imagine we wanted a language with 9 vowels, an unusual language. We wouldn't pick them all close together and up in this corner of the space because our production would have to be very precise to tell the difference between those. Now we could do that. Our production system's capable of doing that. It would take a lot of effort and a lot of energy to get the tongue precisely to those positions and hold it there for long enough to produce a bit of sound. So we use a lot of muscle power and therefore a lot of energy. And so evolution has said that's a poor solution. That's a high-cost solution. And perceptually it'll be high cost because if we don't hear it properly, if it's in noise or our hearing's impaired or some other problem with the communication channel, we'll make a lot more confusions. So it'll be inefficient in communication and it'll be energy inefficient in production. So that'd be a really silly way of configuring our vowel space. A much more sensible way would be to put things at the far corners of the vowel space. So to put things spaced, for example, like this. Imagine we had a language with 4 vowels, put them right in the corners of the space. Now there's some physical limits. We can't produce absolutely every configuration of resonant frequencies. So maybe this one here, down here, is physically impossible. So we're actually going to produce it maybe here instead. But we can see that just through the constraints of not wanting to be too precise in production, wanting to have things very distinctive in perception, we'd want to spread these symbols out as far as possible. So that's one driving force that tells us what vowels we might expect to find in a language. And it's very common that languages have vowels in these corners of the space. There are obvious places to use. It would be silly not to use them. So that's a good thing. The second question we might ask is how many vowels should we have in our language? And there's going to be a tension there. If we just had 2 vowels, it'd be really easy to produce the difference between them. Imagine we only had these vowels here, E right up here and R, or this one right back down here. Just 2 vowels. Really, really easy in production because you just need to get anywhere near them. You could produce this one anywhere around here and it would be fine. This one you could produce anywhere around here and be no problem at all. You could be really sloppy with production, so be really lazy. That'd be good. That's a good evolutionary principle. Perception would be really easy as well. But the language system would be getting very complicated because we'd find it very hard to make lots of different words with only 2 vowels. The words would probably have to be longer because we can only alternate 2 things. So if we had the words bit and bet as being distinctive words, if we wanted to make another word, we've run out of vowels to vary, so we'd have to say bit and bet and bet and so on. Our words will get very long and complicated. So the morphology of the language will get very complicated. The phonology will be very productive. So it might be better to have some more vowels so that we can use shorter signals to communicate the same amount of information. So that's something to do with communication efficiency. We don't want to have to talk for hours and hours and hours to say very simple messages. We'd like to say things in a short amount of time. So there's another pressure on the communication system, and that is to say things in a short amount of time. That's got good evolutionary reasons as well, right? If you're saying run, there's something about to eat you. You don't want to have to spend 10 minutes communicating that with 2 vowels, like Morse code. So you might want to have more vowels so you could say that. So there's some pressures there to have things far apart, and there's some pressure to have more symbols, and languages find their own different solutions to this. But typically languages have something like maybe 5 vowels, maybe 7 vowels would be a very sort of typical number of vowels in a language. But lots of people in this room speak languages that have 5 vowels. So Spanish and in fact Japanese has the exact same 5 vowels. There's lots and lots of languages with 5 vowels. English is a bit of a mess because it got polluted by lots of other languages. We don't count the vowels very carefully in English. Probably more than 5, but it's not 50, and it's not all the vowels. So I think that's enough about how to get from acoustic properties of vowels to some inventory of symbols. And so just to say why it is at all that we can't just communicate with sort of continuous things, why do we go discrete at all? I'm not a phonologist, so I'm not going to give you a theoretical answer to that. It seems reasonable to me that you're communicating about individual discrete things. I want to say that this person's got a different name to this person, or this object's got a different name to this object. So there's some discreteness in the world. So at some point language has to become discrete. The sound system is discrete, the phonology, but the acoustics are continuous. So there's some bridge there between the continuous nature of the acoustics, the fact that formants can have any value in hertz within physical bounds, but the symbols are discrete. And that there is a core problem in speech technology, that the signal is continuous. In its most basic form, it's a waveform. We can get into the frequency domain. If we wanted, we could track the formants, and they would all be continuous numbers. But we need to get from there to words, and words are definitely discrete. They're countable. There's a certain number of them. We can write a list of them. And so we need to bridge between these two things. And this bridge is usually made at this phonetic level. We have phonetic symbols, and then we go to continuous valued acoustics. And at that point, we're going to need some statistical modeling to help us bridge that gap.